So we say that although we want to share those two x origin and y origin between these objects, we still want to theoretically restrict access to them to only functions, to only the member functions of this particular class. If those are made public, they can be accessed everywhere. But as soon as we introduce constructors and start doing the encapsulation of data, this will change. But for now, let's just think that we want those to be shared, and what we want to do is that we want to be able to use it somewhere inside our functions. For example, for whatever reason, I could be doing this now, right? I can access plus x origin and plus y origin. I don't know why I'm doing this, but I'm just bringing up the example how I could use this, like a normal variable. But the only difference is that if each x and y is unique to every instance of my objects, then x origin and y origin is the same. And if someplace I change those values, they will be the change will be instantly visible to all of my objects. Now, it makes sense then to also add something that would to this code that would make a possibility to go and change those two static variables, for instance, sometime early on when the application just starts. Because maybe it would be reasonable for me in my main function to do something like this, to say, even before I create my first point, it's going to need the x origin and y origin to make anything meaningful. For that reason, I may be able to, well, first of all, I can add this function, static, perhaps void, set origin. Right? Set origin, and pass the same set of parameters, x and y, but those will be set as the origin that I want to set. The implementation of this static function may look like this. Void, of course, it still belongs to the point class, so I need to qualify the name of my function, set origin, right? So that's the name of the function. It takes the same set of parameters, so I can quickly copy and paste here, right? And I should be able to do this, just basically set it, just set those two. Let's see if we can make those little changes. Say x origin is set to xx, and then y origin is set to yy. Okay, so these are static variables. These are local parameters. This is the way I would call this function, because the function is also declared static. This function basically says that you can call me without requiring the user to instantiate an object. For example, I can say point. Point is the name of the class, and inside that point name of the class there is set origin. And so I can make a call to this function and say, you know, let's set the origin to 0, 0, something like that. And that would make a call to this function set origin. Let me move this implementation file to here, maybe, right? So this call will go directly here, and it will update x and y origin, and they will be updated before even I create any instances. So these two variables will be ready to go, set and ready to go. And then by the time I create a point, those two will be perfectly set. So this is the nature of the static variables. It is not a requirement to call a static static function by specifying the name of the class, I can still call this same function by saying, by using point and set a different origin here, right? So, but most people, so this syntax is permitted. You can still use the name of your object and say, hey, this object has this function. Yes, it's sort of like a static function right here. If you look at it, it's declared static, which means that it doesn't require an instance. In fact, it completely ignores the fact that I provide a particular instance of point to make a call. It just says, okay, sure. I mean, I can ignore this. All I need to do is to make sure I update those two variables. So static variables are very much like global variables, but they are limited to facilities that we define for our classes, primarily. But now look also at the fact that a regular function, adjust, is not a static function. We created this a long time ago. It's a normal member function. It does require the object on which it can be executed, but in this case, this function has no restrictions on going ahead and accessing those two static variables. So that's the nature of static variables. We're going to see them again. I kind of try to postpone this part of our class. When we go to work with graphics, all of this is going to be part of it. You're going to see examples of it used directly and the decisions that were used. Yes, question, Kyle?
In like Java or like C# I've been playing with lately, you can still change static variables even if you don't have an instance of that class up. Can you still do that?
Absolutely, yes.
Okay.
Yes. Yes, you can. And it's a normal practice.
Okay.
Yeah. I mean, typically this type of initialization takes place early on, and then you begin to use objects.
Okay.
There is something I want to say. Let me check the timing on this presentation. Okay, maybe a couple of more minutes. Something I would like to say about the static variables. Because they're just like global variables, they are actually evil. Unless you absolutely have to have them, don't use them. Because in multi-threaded program, which is trying to ask the operating system for concurrent threads of execution, if those parallel executions inside your program are attempting to access, and I'll give you an example. When you open your browser and you click on a web page, and the web page may be partially loaded, but you can already click on the link, so that because the user interface thread already is waiting for you to give some, so that user can do some actions here, whereas the worker thread that loads all this information may still be running, right? So the pages still can still be loading, but I can already click on this link and go away from this page. So that means that there are at least two threads of execution that have different responsibilities and assignments. So if that's the case, static variables become a huge problem. Global data becomes a huge problem because now you have to create the so-called critical sections, or some other facilities implement some other synchronization models to make sure that those static variables are not written by two different threads at the same time, because the result will be garbage. Okay, so unless absolutely necessary, don't use them. It's just and we'll talk in the future about alternatives, what can be done alternatively to those. In some way, if you say, I do this only once per lifetime of my entire application, and I run this initialization and I know exactly who does that and when, it's safe, right? Or you can say, you can stop other threads and make those adjustments while the user pauses the game or something. So still, you have to kind of worry about it. But in general, if it's done once and early and is just part of your configuration, that's okay. But in cases if those variables may change at any point by any thread of execution, that's a big concern. So I want to discourage you from thinking that this is normal. This is a very special case and needs to be given serious consideration, because the safety, your code becomes thread unsafe in many places where you just recklessly introduce static variables. So goes for the global variables.